Good morning, dear students. This is our second lecture. So, see, in next today's second lecture, we are going to learn the linear programming problem. The actual main part of this chapter is linear programming problems. Okay. So, see that what is the LPP? So, LPP is an optimized techniques used for different fields such as management, planning, production, transportation, etc. It is developed during a second war to optimize utilization of limited resources to get maximum profit. It means in less things we have to get maximum profit. How we'll get it? So that techniques are in LPP are there. So LPP programming is used to minimize the cost of production. What is there? To minimize cost of production and maximize profit. LPP using the techniques to minimize cost of production and maximize profit. The problem are related to efficient use of limited resources like raw material. Limited resource of material, that is raw material we are using limited, manpower, availability of material, machines, time, cost of material, and so on. So those things will be used the minimum thing, and instead of that we have to take maximum profit. That way we will do the planning. So that planning will be done by LPP, linear programming problem. So linear programming problem is a mathematical technique designed to help manager. These are techniques to help the manager in planning and decision making. Programming problems are also known as optimization problems. The mathematical programming involves optimization of a certain functions called as a objective function. So in that case one function will be there. So that will help us to find that solution. So that function is called as a optimized solution that decides maximum or that decides minimum. Okay, subject to given conditions. So respect that the conditions will be there, that equations subject to conditions. So that conditions or restrictions are known as a constraints. So already we done the examples in a linear program problem. The constraint means what? All the equations with inequations, all the inequations we already done. So that inequations are the constraints, that 2x plus 3y less than equal to 10, like an example we already done. So like that all the less than equal to, greater than equal to, all inequations, these are constraints, and that constraints are belongs to one equation, that objective function. Okay, so see, these are things you have to learn. Have you get that? So the meaning of LPP. So linear implies all the mathematical functions condition contains variable of index at most one, and the LPP may be defined as a problem of maximizing and minimizing the linear function subject to linear constraints. So what is the LPP? LPP defined to be problem of maximizing and minimizing a linear function subject to linear constraint. These constraints may be equations or inequations. Okay. So for this, so now formally define the following LPP as a follow. Define terms related to LPP as a follow. First, the decision variable. So decision variable means what? The variables involved in LPP, the variables involved in LPP are called decision variables. For example, 2x plus 3y is less than equal to 6. So x and y, these are the variables. So how the values of x change? Same way value of y will be changed, and respected result will be changed. So that is this is decision variables. Then objective function, a linear function of a variable. See what they say, the linear function of a variable which is to be optimized, either maximize or minimize. Either we will check the maximum thing, that is profit will be maximum, and then minimum will be cost. Okay, so that is, it's called as an objective function. The constraints, the conditions under which, constraint means what? The conditions under which objective functions is to be optimized are called constraint. The conditions that respect to that variable, there should be the conditions. So that condition either less than equal to or greater than equal to, those conditions we have to check, and that equations are the constraints, and these constraints are in the form of equations or in equation. Equations means equality will be there, and in equations mean less than equal to or greater than equal to will be there. Okay. Then last will be non-negativity of constant. So it means what? They always our production will be more than 0 or 0. But we can't say that our production is a negative or our loss is negative, our profit is a negative. Is not possible. So that means what? Our result will be non-negative. So in some situation the values of variable under the conditions may be positive or 0 due to imposed constraints. Such constraints are referred to be non-negativity constraint. That is x greater than equal to 0 and y greater than equal to 0. We already done. And for that always we are showing our optimal solution in first quadrant. Okay. So these are the 4 important points in LPP. Okay. So now we are going to learn mathematical formulation of LPP. Write on that, mathematical formulation of LPP, that is linear programming problems. Okay. So first step 1. What is step 1? Identify the decision variables. Why? Okay, identify decision variables x, y or x1, x2 like that. X, y, z, x1, x2 or maximum x, y, not x, y, z or x1, x2, any one of them. Step 2. Identify objective function which to be maximize or minimize. Okay, in terms of variables, in the terms of variable. Okay. And step 3, identify different equation constraints and express them as a mathematical equations or inequations. Okay, that we have to do. You get it? So these are the 3 main steps, and last step, step 4, define non-negativity. Okay, define non-negativity. Okay, so these are the important steps we have to learn. Now see that in board from this chapter the 2 type of questions are possible. First is more than 70 to 80% the question is that draw the graph and find solution. Okay, but there is a 80% chances that the word questions will be given. In that word questions we have to find all the equations by using these 4 steps, and then we have to solve with graph. Likely also question will be possible for the board, but it is a chance is a 20% or less than 20%. Okay, but maximum chance that questions from the next part, that is draw the graph and find solution related to maximize or minimize. Okay, but we'll start with the first part with the formation of LPP, and afterwards we'll see that solution of LPP. Okay, so for the formation of LPP we have to check first examples from our exercise. So see that examples are given. So see what is the question given, that that questions must you have to be just open your textbook exercise 7.3. Okay. I think I have to remove that part. Okay, you done that, written that part. See, question is that writing question there. A manufacturing firm produces two types of goods. A, two types of gadgets A and B, which are first process in foundry and then sent to machine shop for finishing. Okay, the number of man hours of labor required in each shop for production A and B, and number of man hours available for the firm are as follow. Gadgets, foundry, machine shop. Gadgets A, B, and time available. In R is given that 10, 6, 60, 5, 4, 35. Profit on the sale of A is rupees 30 and B is rupees 20 per unit. Okay, formulate LPP to have maximum profit. Okay, so this is a question. Please read that question properly. Read it. See what is the question is that a manufacturing firm produces two types of gadgets A and B. A and B, which are the first produced in a foundry and then uh, sent to machine machine shop for the finishing. The number of man hours for available labor required in each shop for production A and B and number of man hour available for the firm are as follow. So see that gadget table is given that gadget foundry and machine shop. So A gadget foundry 10, machine shop 5. Okay, it means what? 10 foundries are there where they are producing their products and 5 machine shops are there where they are sending to finishing. Okay, for the gadget B there are 6 foundries are there and there are 4 machine shops are there. But total available for the labor for the first foundry is 60. It means labors in the foundry are the 60 hours and in machine shop it is a 35 hours. Okay, so for this we have to prepare our LPP, that is linear programming problem. Okay, and for that see what is given there. The profit on the sale of a gadget A is rupees 30 and gadget B is rupees 20 per units. It means once a product, single product, when you solve A, that times profit will be 30 rupees and for B 20 rupees. For that formulation of LPP to get maximum profit we have to do. Get that? So first thing is that what is here in that example there are two types of gadgets we are going to produce. So first, and that gadgets are to produce at a foundry. First the foundry they are going to that produce and they are sending to the machine shop. So two things are there, one is a foundry and one is a machine shop. So in foundry some labor will be there and machine shop some labor will be there. Okay, so that labor will take that time and machine shop also that they will take that time. Okay, so see that. So in for the first gadget A, there is a 10 hours required in foundry and 5 hours required in machinery shop. And for the gadget B, 6 are required in foundry and 4 are required in machine shop. Okay, and then total available time is there. So first we'll assume that how many gadgets we are going to produce. So let X let manufacturing firm produces X units of gadget A and Y units of gadget B. Get it? What they are doing? Let manufacturing firm produces X units of gadget A and Y units of gadget B. So X and Y are decision variables. Okay, so first step of the LPP is that define variables. So that step we done. Okay, now the second step. For the second step we have to check which is the optimal function, optimized function. So for the optimized function, what is the main aim? We have to find that profit. Okay, so now X units of gadget A they are going to produce and Y units of gadget B they are going to produce. But when you selling 1 unit of gadget A, 30 rupees you are getting. So when you will sell X units, you will get 30x times of profit from gadget A. And same way 20y times profit from gadget B, and that is our optimized function. And that mainly explained with that equation we are giving. Their name is Z. Variable we are using for the optimized function is Z. Okay. So next line, let Z be the total profit so on selling of A on selling profit of A is rupees 30 and of B is rupees 20 per unit. Okay, therefore total profit on selling X units of A and Y units of B is given by what? What is the 1 unit? 30. So what X unit you will get 30x. So it is a 30x plus total profit. So total addition is plus 20y, and we are showing it as a z. So z is equal to that, and which you are going to do maximum z is equal to 30x plus 20y. Okay. Now next we are going to write the condition. The conditions are, what is the condition? See, for foundry, how many hours required? 10 hours for gadget A, 6 hours for gadget B, and our time is 60 hours. So whatever the hours will be used in foundry, that will be what? Will be 60 or less than 60, not more than 60, because 60 only hours we have. So that is, we have, what we are going to use the sign less than equal to greater than equal to 60 or less than 60 or less than 60. So what sign? Less than equal to sign. So see, how many gadgets? X of gadget A and Y gadgets of B. So how many hours will be required here? 10x and 6y, and here 5x 4y. Okay, so what are the equations? 10x plus 6y, and now it is a time is 60 only, so it is not exactly equal to 60, so it is a less than equal to 60. Get it? Similar way, 5x plus 4y less than equal to 35. Get it? And now non-negative is, for negative what? The production is non-negative, so therefore x is greater than equal to 0 and y is greater than equal to 0. Get it? So now write it properly. Last, maximize z is equal to 30x plus 20y subject to, so what is subject to what? Constraints. 10x plus 6y less than equal to 60 and 5x plus 4y less than equal to 35. X greater than equal to 0, y greater than equal to 0. So this is the way you have to write. Okay, and such example will be asked in exam for 3 marks. So for in that 3 marks, 1 mark for finding optimized function, 1 mark for finding conditions properly, and last 1 mark for explanation of that maximum and subject to part. Okay, so learn it properly. See, these are the word questions are there, but these are the word questions are very important with respect to board exam. So please check the solution. Still, if you have any doubt, please let me know. Get it? So this is the example related to profit. Now one example we'll do for minimize. Okay, and then we'll stop with this lecture. In the remaining time you have to solve the questions today only in given time and give me that solution in assignment. Okay, so then I will understand you clear with this type of example or not. This type of questions is not difficult one, these are the easy one, only properly you have to explain it. Again I will write the question on the right hand side. In a cattle breeding farm, it is prescribed that the food ration for one animal must contain 14, 22 and 1 units of nutrients A, B and C respectively. Okay, two kinds of fodder available. Each unit of these two contains the following amount of these three nutrients. Okay, this is a required nutrient. What is given that must contain 14 for A, 22 for B and 1 for C. Okay, so see that what is the question is that, and the cost of fooder one is rupees 3 per unit, and that of fooder 2 is rupees 2. Formulate LPP to minimize the cost. So in minimum cost we have to arrange these things. Okay, see that. So in cattle breeding firm, it is a prescribed that the food ration for one animal must contain 14, 22 and 1 units of nutrients A, B and C respectively. So for that animal there is a requirement of 14 of nutrient A, B 22 and nutrient C 1 units required, and two kinds of food are available. So two kinds of foods are available. So in that foods, how much type of nutrient A is there, nutrient B is there, nutrient C is there, that is mentioned over there, and how much is required, that is given there. So now in that case, see, so whatever the foods we are going to supply, so in that foods they have to give maximum thing, but that must be their need. What is they say must, they want 14, so 14 they have to give it. More than 14 given, no, okay, no problem. Nutrient if is there, no problem, but must be more than 14. 14 they want. Similar for nutrient B, they want 22. Nutrient C, they want 1. So that must be 1. So what is the condition for that? It is a must be or equal to, more than equal to, what is that? Greater than equal to case. So it is a 14 or more than 14, that is greater than equal to constraint we are going to use. Get it? So now start with the thing. So see, cost is given the fooder. So what are you going to write? So we are going to use X units of fooder 1 and Y units of fooder 2 will be given to animal. Let X units of fooder A1 and Y units of fooder 2 will be given to animal. Okay, get it? So now for that 1 unit they given a cost rupees 3. Fooder 1 cost is rupees 3, and you are using X units of fooder 1. So what is the cost for the X units? Respect to 1 respect to 3 rupees per unit is, that is 3x cost for fooder 1, and similar way 2y the cost for fooder 2. So and that total cost is our minimum cost. Okay, so next line. So let Z is minimum minimize cost function. Okay, the cost of fooder 1 is rupees 3 and fooder 2 is rupees 2 for per units. Therefore the cost of X units of fooder 1 and Y units of fooder 2 is, what is that? 3x plus 2y, and this is our optimized function. So therefore Z is equal to 3x plus 2y. Now come to the conditions. Okay, conditions are, see, now for the nutrient A, from fooder 1 you will get 2 units, 2, and from fooder 2 you will get 1. Okay, but total requirement is a 14, must be 14, so it is more than 14 if there, no problem, but minimum 14 we have to give it. Okay, minimum 14. Okay, so maximum how much you are getting, no problem. So for nutrient A, what is the equation? So but how many fooders are there? X and y. So for nutrient A you will get 2x plus y, which is greater than or equal to 14. So it is a more than 14 or more than 14, but not less than 14. Similar way, 2x plus 3y greater than or equal to 22. X plus y greater than or equal to 1. So these are the constants. And now whatever food we will supply, that will be non-negative. So therefore x greater than or equal to 0 and y greater than or equal to 0. So our main part is minimize. What is our minimize function? 3x plus 2y subject to, what are the constants? 2x plus y greater than or equal to 14, 2x plus 3y greater than or equal to 22, and x plus y greater than or equal to 1. X greater than or equal to 0 and y greater than or equal to 0. Non-negativity part. This is our required solution. So please check that solution properly and learn it. Okay, so see, this is the two types of questions we have to solve, either with that minimize or maximize question. Now in the exercise there are so many questions are there. So first you try one question and then we'll check that you are able to understand or not. Otherwise, if there is a need to solve more questions related to that, I will explain it. Okay, so those questions are not difficult ones, these are the easy one questions. So see, I will give the question from the exercise, so that I will give in that assignment which question you have to solve from the textbook. So that question you have to solve on the paper, take a photo and send to the assignment. Okay, but that we have to do in time. So today this is our lecture of 35 minutes or 40 minutes it done. So in remaining 20 minutes you have to solve one question, only one question you solve it, but properly solve it and submit it. Get that? And that I will understand you able to, you get all the points are clear or not. If you have any doubt, then I will get it. But try that solution properly. Try to make the table format things. If you done the table format for all examples, then easy to write the equations. That shows all the things in simple format. So try to write the table format first. That learn it. But table always will be not given. Sometimes you have to draw the table. So roughly draw it. Not say that you have to draw in solution. Solution is this much only. Your objective variables, decision variable, then objective function, conditions, and last part equations all together. That you have to write. The table, word questions, don't need to write. Is it clear? So check those things properly and do it. Get it? Thank you.